Have you ever wondered how your phone knows exactly where you are, or how a pilot can fly a plane across a huge ocean and land in the right city? The secret is an invisible grid that wraps all the way around our planet, the Earth. It's not something you can see or touch, but it's one of the most important ideas in science. This grid is made up of imaginary lines called latitude and longitude. By using these lines together, we can give a unique address to every single spot on Earth. From the top of Mount Everest to the chair you're sitting in right now. It's like a giant piece of graph paper covering the whole world. Consider it. Every place has its own special coordinate. This system is the foundation for how we navigate, map, and understand our world. Think of it this way. If you wanted to meet a friend in a big open field, you couldn't just say, "Meet me in the field." That's not very specific. But if you said, "Meet me 10 steps north and 5 steps east from the big oak tree," your friend would know exactly where to go. Latitude and longitude work in a very similar way, but on a much bigger scale. They give us a common starting point and a way to measure distance, so that people all over the world can agree on where things are located. It's a universal language for location. But where does this global grid start? For any good map, you need a starting point, a zero. For our Earth grid, we have two main starting lines. One is called the equator, which runs around the middle of the Earth like a belt. The other is called the prime meridian, which runs from the North Pole to the South Pole, through a place called Greenwich, England. Every other line of latitude and longitude is measured from these two important lines. This system turns our big, round planet into a map that we can easily read and use for all sorts of amazing things, from exploring the deepest seas to sending satellites into space. This grid isn't just for maps, it's a fundamental tool that helps us organize our world. It helps us understand patterns in our climate. Because where you are on the grid can tell you if a place is likely to be hot or cold. It helps us organize time itself, which is why your friend in another country might be waking up just as you're going to bed. This incredible system of lines, invented by clever thinkers a long time ago, is still at the heart of our modern high-tech world. So next time you use a map on your phone, remember the invisible grid that makes it all possible. Science is all around us. Let's start with latitude. Lines of latitude are the horizontal lines you see on a globe. They run east and west, parallel to the equator. That's why they're sometimes called parallels, because they never, ever meet. Think of them like a stack of rings getting smaller and smaller as they get closer to the top and bottom of the Earth. The biggest ring of all is the equator, and it's our starting point. We call the equator 0 degrees latitude. From there, we measure how far north or how far south a place is. It's like climbing up or down a ladder, where the equator is the middle rung. When we measure north of the equator, we count up from 0 degrees all the way to 90 degrees north, which is the exact point of the North Pole. If we measure south of the equator, we count up to 90 degrees south, which is the South Pole. So, a city's latitude tells you its north-south position. For example, New York City is at about 40 degrees north latitude. That means it's a little less than halfway from the equator to the North Pole. A higher latitude number means you are farther from the equator and closer to one of the poles. This is a very big deal for something we all talk about: the weather. The latitude of a place has a huge effect on its climate. Places near the equator, at low latitudes like 0 to 23.5 degrees, get the most direct sunlight all year round. That's why these regions are so warm and tropical. As you move to higher latitudes, like where Europe and much of the United States are, the sun's rays hit the Earth at more of an angle. This spreads the energy out, making these areas cooler, with distinct seasons. And if you go to very high latitudes, near 90 degrees north or south, you're in the polar regions. It's very cold there because the sun is always low on the horizon. For centuries, sailors had a clever way to figure out their latitude. In the northern hemisphere, they would look for the North Star, also called Polaris. This special star sits almost directly above the North Pole. By measuring the angle of the North Star above the horizon, a sailor could figure out their latitude with surprising accuracy. If the North Star was 30 degrees up in the sky, they knew they were at 30 degrees north latitude. It was like having a giant celestial signpost in the sky, guiding them on their long journeys across the dark, open ocean. It was a brilliant use of astronomy for navigation. Now let's talk about the other half of our grid: longitude. Lines of longitude, also called meridians, are the vertical lines that run from the North Pole straight down to the South Pole. Unlike latitude lines, they are not parallel. They all meet at the poles like the sections of an orange. These lines help us measure how far east or west a location is. But to measure east or west, we need a starting line. For a long time, different countries used their own starting lines, which was very confusing. Finally, in 1884, everyone agreed on one starting point, the prime meridian. This line runs through the Royal Observatory in Greenwich, London. The prime meridian is 0 degrees longitude. From this line, we measure 180 degrees to the east and 180 degrees to the west. The 180-degree line on the opposite side of the world is called the International Date Line. So, when you see a location's longitude, it will be labeled with an E for east or a W for west. For example, London is right on the prime meridian, so its longitude is about 0 degrees. New York City, on the other hand, is at approximately 74 degrees west longitude, meaning it's 74 degrees to the west of Greenwich. Together, latitude and longitude give us a precise address for any place on Earth. Finding your longitude was historically much harder than finding your latitude. You can't just look at a star to figure it out, because the Earth is constantly spinning. The solution to this longitude problem was one of the greatest scientific challenges of its time. The key was time itself. To know your longitude, you need to know the time where you are, which you can find by looking at the sun, and the time at a known location, like Greenwich. The difference between these two times tells you how far east or west you are. But how could a sailor keep track of the time in Greenwich while on a rocking ship for months? The problem was solved by a brilliant self-taught clockmaker named John Harrison in the 18th century. He invented an incredibly accurate clock called a marine chronometer. This clock could keep perfect time even on a rough sea voyage. A sailor could set it to Greenwich Mean Time before leaving port. Then, each day at noon, when the sun was at its highest point in the sky, the sailor would check the time on the chronometer. For every hour of difference between their local noon and the time in Greenwich, they knew they had traveled 15 degrees of longitude. It was a revolutionary invention that made global navigation safe and reliable. So, we have latitude for north-south and longitude for east-west. When you put them together, you get a coordinate pair that can pinpoint any location. This is the magic of the grid system. For example, the beautiful city of Paris is located at about 48.86 degrees north latitude and 2.35 degrees east longitude. The Great Pyramids in Egypt are found near 29.98 degrees north, 31.13 degrees east. These coordinates are the basis for all modern GPS technology. When your car's navigation system tells you to turn left, it's because a satellite in space has used this grid to figure out exactly where you are and where you need to go. This grid does more than just guide our cars and phones. It is essential for so many fields of science and technology. Meteorologists use coordinates to track the exact path of hurricanes and storms, helping to save lives by giving people time to prepare. Geologists use them to pinpoint the epicenter of an earthquake, which helps us understand the Earth's tectonic plates. Pilots file flight plans using a series of latitude and longitude coordinates, creating a precise highway in the sky that keeps air travel safe and efficient. Every time you see a weather map or a news report about an event somewhere in the world, that invisible grid is working behind the scenes. One of the most direct and fascinating connections is between longitude and time. The Earth takes about 24 hours to rotate a full 360 degrees. If you do the math, 360 divided by 24, that means the Earth spins 15 degrees of longitude every single hour. This is the scientific basis for our time zones. The world is divided into 24 standard time zones, each one roughly 15 degrees of longitude wide. As you travel east from the prime meridian, the local time gets 1 hour later for every time zone you cross. If you travel west, the time gets 1 hour earlier. So, longitude doesn't just tell you where you are, it also tells you what time it is. From ancient sailors gazing at the stars to the complex satellites orbiting our planet today, the quest to know where am I has driven incredible innovation. The simple, elegant system of latitude and longitude is the answer to that question. It's a grid that organizes our planet, connects us globally, and empowers our technology. It helps us predict the weather, respond to disasters, and even organize our day. Understanding this grid isn't just about geography, it's about understanding how we've made sense of our place in the universe. And that is what science is all about.